In this lesson, second part to using Lewis structures to show how compounds are formed, I would like to discuss the examples where different elements combine chemically. Next, I want to show you how different elements combine. So we've got hydrogen with one valence electron and its Lewis structure showing 1 cross and its valency is 1. Now let's look at hydrogen and fluorine when they combine. Fluorine has 7 valence electrons. So if we take hydrogen joining up to fluorine, how many bonds can fluorine form? 1. So when hydrogen shares its 1 electron with fluorine, this is what the Lewis structure will look like. Now when the different atoms starts combining, we can use the valencies to figure out the formula. So I'm going to show you in the last few moments of this video. Hydrogen has a valency of 1 and fluorine's got a valency of 1. It means that hydrogen can form 1 bond, fluorine can form 1 bond. We can, instead of crosses, use a line to show the bond between hydrogen and fluorine. And the formula is HF. And the name of this compound, now this is the first compound we are looking at, is hydrogen fluoride. Right, so from now on, the next video will show you how we write the formulas of different compounds in a similar way. Thank you for watching. Welcome back. I would like you to try the following because we've already discussed hydrogen. I want you to complete the table for hydrogen, and chlorine is similar to fluorine. So I'm going to give you a chance to get to the formula of hydrogen chloride. And I'll discuss that a bit later with you. The next compound I want us to look at is the compound formed when hydrogen joins with oxygen. Now we know that hydrogen's got 1 valence electron because it's in group 1, and oxygen's got 6 valence electrons because it is in group 16. So the Lewis structure for hydrogen is an H with 1 cross, and the Lewis structure for oxygen is an O with 6 crosses, where 2 of these crosses are by themselves. Now, with group 1 elements, if it's got 1 valence electron, it can form 1 bond, so the valency is 1. With the group 16 element, there are 2 electrons that needs to be shared, so the valency is 2. So if we look at the bond formed between hydrogen and oxygen, you'll have the oxygen with its 2 pairs of electrons, and one of these alone, the single electrons, will be shared with the electron of hydrogen, and the second single electron from oxygen will be shared by a second hydrogen. And we can use lines to represent the bond between the oxygen and the hydrogen. So the oxygen joins up chemically with the hydrogen, and another hydrogen And the formula for this compound is H2O, and I'm sure you are familiar with this compound. It is water, or some people might say it's hydrogen oxide. Right, now I'm going to give you a chance to do one by yourself, and that is when hydrogen forms a bond with sulfur. I'm going to give you quite some time to do that one by yourself. I know that sulfur is in the same group as oxygen, so it should act in a similar way, and the compound's name will be hydrogen sulfide. Right. Next, I want us to look at when hydrogen forms a bond with nitrogen. So, hydrogen, easy by now, it's got one valence electron, its Lewis structure's got one cross, and it can form one bond. Nitrogen is in group 15, so it's got 5 valence electrons. So the 5 valence electrons are 2 will be together, one alone, another one alone, and a third one alone. So the 3 electrons that are alone, they will tell you how many bonds the atom can form, and that is 3. So if I draw the Lewis structure for nitrogen, there are 3 places where hydrogens can share um, the electrons of nitrogen. So 3 hydrogen atoms will come along and share their electrons with one nitrogen atom. And we can use lines to represent the bonds that are formed between the nitrogen and the hydrogen. And the formula for this is NH3. And this compound's got a special name. Its special name is ammonia. And that is what you smell in Handy Andy. Now for your practice, after copying this, try the compound formed when hydrogen combines with phosphorus. And the real name is phosphorus trihydride, or phosphorus trihydride. There is one last one I'd like us to do. The last one I want us to go through is the most complicated one that we have discussed so far, and that is about carbon, where carbon is in group 14. It's got 4 valence electrons, and I shared with you before that these valence electrons can be written on the 4 sides of the carbon atom, and because there are 4 unshared electrons at this point in time, the valency, the number of bonds that the carbon can form, is only 4. Oxygen, on the other hand, is in group 16. It can form 6. It's got 6 valence electrons, of which 2 will be together, 2 will be together, 1 will be alone, and another one will be alone. So oxygen can form 2 bonds. Now, if carbon can form 4 bonds, and oxygen can form only 2 bonds. Then the carbon will form 2 bonds with 1 oxygen, and it will form another 2 bonds with another oxygen atom. Now I haven't looked at this in detail, but we can go through the stability thing. If we look at oxygen, it wants 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, to be stable. This oxygen wants 8, 1, 2, 3, 4, 5, 6, 7, 8. The carbon, on the other hand, also wants 8. So 1, 2, 3, 4, 5, 6, 7, 8. So if we want to, we can represent these bonds by lines. So carbon and 2 lines will represent the 4 electrons shared. 2 lines will represent the 4 electrons shared. So the formula is CO2, and I bet you recognize this formula as well. It is carbon dioxide. Right, last one I want you to try alone is when hydrogen joins to carbon. Thank you for watching. I hope you come right. We will talk again.